Okay, so I put together a talk last month for a fisheries conference, and there's some things that my advisors insist on. One is that I use scientific names. I never do that I'll never do that in any other case, so I apologize. But what I'm looking at are the seasonal effects of ammonia and dissolved oxygen on trout and catastoma, which are suckers. Okay. The other thing that for this talk, all my measurements are in metric units, so I apologize for that. I didn't take the time to transfer those. But I'm a graduate student at Montana State, and I've been working on silverbow since 2009. In 2009, we sort of had a pilot study year where we did some spot sampling here and there just to try to get some kind of idea of where there were fish and where there weren't. We didn't know, our idea originally was to look at movements of trout, and we didn't know, we knew there were trout in the tributaries in pretty good numbers, but we had no idea would we even see any fish move into silverbow. And originally we were thinking about this as sort of a connectivity study. But after the first year, we actually sampled in Silverbow Creek in Durant Canyon and found actually there were quite a lot of fish. And as you got into Blacktail Creek and even into the LAO, while there weren't as many as in Durant Canyon, there were trout. But what we found was that there was a large section where it didn't look like there was almost any trout, but we were finding some suckers. And so that's what I'm going to talk about today is kind of investigating that question. So why are we seeing what looked like a large section of the stream where we weren't finding much of anything as far as trout? And knowing that trout is one of the primary goals, restoration of self-sustaining trout populations was a primary goal of the restoration project. That's sort of what we wanted to focus on. So first of all, I want to thank Fish, Wildlife, and Parks, the Natural Resource Damage Program, and recently we got some funding from the Greenway Service District for the project. I absolutely want to thank Trevor and Jason and Pat for equipment, for labor, for expertise, for the project. I've sort of taken on a pretty labor-intensive project, and when almost everything I've got is loaned, and when something is loaned to me, it takes away from things they do, and so I certainly want to thank them, and I'm well aware that I take away from what they're doing. I want to thank ARCO and the Butte, Silverbow County, and a couple landowners who have given me access to property, which particularly with ARCO, if I didn't have access to the LAO section, I'd be in some trouble. Chris Gammons and Steve Parker have allowed me to use their lab and have taught me what to do to do some of the ammonia sampling, and certainly I want to thank the field crew that has worked with me. Shane is here. Ben especially, Ben Whiteford, if people are familiar with him. He's put in a lot of work. So thanks to Matt, I don't have to go through as much of this, but Silverbow Creek, of course, runs west and north from Butte. The remediation, I think it's a NRD figure, but the remediation as of 2010 was complete down to Miles Crossing in sub-areas 1 and 2. That's, as stream kilometers, it's about 20 kilometers. It continues, sub-area 3 is primarily the Durant Canyon section, and some sub-area 4 begins, I believe, at there's an impoundment at Fairmont Road, and it continues down to the Worm Spring Ponds. In 2009, we did look a little bit in Durant Canyon. We sampled here, and we sampled pretty extensively in German Gulch. But in 2010, the data I present today, we avoided that because they were actively remediating, and we felt like it was going to, understanding how the fish were behaving would be compromised if they were sort of stirring up tailings and that sort of stuff. So like I said, I've got one slide that's going to cover what Matt covered in 40 minutes. But essentially, of course, Silverbow Creek was contaminated by mining. There are reports as early as 1891 that there were no fish in Silverbow Creek. Some of these pictures are actually from CFWEB. But essentially, you're looking at a pre-remediated stream that's absent of vegetation. And then during remediation, they remove the floodplain, they rebuild the channel, and what's left is a stream channel that, at least in my opinion, doesn't look like primary trout habitat. So it's generally fairly wide, it's fairly shallow, and it tends to have, at least at the point, this is right above Miles Crossing, so it's immediately after it was fully remediated. There's not a lot of vegetation, but when you see the scale of the project, you understand why it would be difficult to recreate this sort of multi-threaded. So when you actually look at these former photos, you see there's actually some habitat complexity here, but you can't recreate that with backhoes. And so originally I thought maybe this has a big effect on why we're not seeing these fish in part of the stream. But what remediation maybe lacks in style, it makes up for in reductions in heavy metal, which is the original point. So we're looking at copper and zinc concentrations from 93 to 2009. I have sort of a rough guess somewhere in 1998 of where the remediation started. These are log transformed scales. But what you see is you have, in both copper and zinc, you have a dramatic reduction in concentrations in the stream. This is the USGS gauge right at Interstate 90 as it leaves Butte. I have these squiggly lines here are the EPA acute and chronic standards. And while copper still occasionally exceeds even the acute standards, it's not exceeding anywhere near the extent that it was historically. And zinc, at least based on this gauge data, hasn't exceeded since 2005. So it is a dramatic reduction in heavy metal concentrations. And as a result, and again, I think we have the same fish here, there are now populations of 6 fish in Silverbow Creek. And what's very exciting, at least to me, is that we have populations of West Slope cutthroat trout that are, in Montana, a species of special concern. And not only that, they're from a population that is quite genetically, I should be careful the term I use, but it's quite genetically pure. It's a uniquely pure strain, not pure entirely. But we do have rainbow trout that we found in our sampling, although in relatively low numbers. But there are still problems, as Matt sort of foreshadowed, and that's that the stream is eutrophic. That means it receives too many nutrients. The nutrient of primary concern is ammonia, and based on the work of Bev Plum, who was a graduate student at Montana Tech, we know that 80% or more of the nitrogen loads in Silverbow Creek are actually coming from the sewage plant, and they're in the form of ammonia. As the ammonia is nitrified or is oxidized and becomes nitrate, you have this biochemical oxygen demand that leads to hypoxic zones downstream. There was a very recent paper from Steve and from Chris Gammons and others that showed that actually the rate of dissolved oxygen drop on a 24-hour cycle is among the highest in published studies. So Silverbow Creek is an extremely eutrophic stream. And we understood that trout are very sensitive to dissolved oxygen, and so we wanted to look very carefully at how this hypoxic, what that effect would have on the trout distribution and the trout abundance. I'm going to put this down before I shoot it at anybody. And so, but what we really needed to know is how does this hypoxic zone vary seasonally and spatially, and how is that going to correspond to our fish distributions? So while our overall question is about the remediation and how successful has that been in reestablishing trout populations in Silverbow, we wanted to approach that in 3 steps. We wanted to understand what are the fish distribution patterns, and then understand how do those relate to heavy metal concentrations in the stream, to habitat quality in the stream, and then to water quality in the stream. And so we sort of approached it to describe the fish distribution patterns. We started out at Miles Crossing and we conducted continuous electrofishing surveys throughout the 25 kilometers of Silverbow Creek, well, 20 kilometers of Silverbow Creek to what I call to the Metro Storm Drain, and then another 5 kilometers of Blacktail Creek. We also conducted about 3 kilometers of Browns Gulch, which I'm not going to present that data, but when we electrofish, we capture every fish that we can get our hands on in 100 meters, and then we would insert a small tag in those fish that I can demonstrate later. And each trout that we catch over about 120 millimeters, so 4 inches, and a small subsample of suckers of over about 5 inches, we would implant with tags. And then using those tags, what we hope to see is how those fish, once we established what the pattern was in July, we wanted to see how those fish had sort of redistributed themselves in August and then again in December. And in the meantime, we also wanted to monitor as best we could the water quality conditions and how those changed in Silverbow Creek. So the orange dots here are 24-hour dissolved oxygen monitoring devices that we placed in the stream. Here in purple is the sewage effluent. Those monitoring devices gathered hourly data, and then along with that, in the spaces in between, well, essentially in the entire survey area, I would go out during this, while we were conducting these fish surveys, and collect spot measurements of dissolved oxygen during the night. So between 3 a.m. and about 7 a.m., I would just take as many as I could get and then go shock fish. So there were sort of limits on how long I could, how many spots I could get. And then also, I would occasionally try to get ammonia samples. I actually only got 4, and I'm going to present 3 today. But those I tried to get about every 2 to 3 kilometers. So not quite as many as the dissolved oxygen. So now the more interesting stuff, and maybe for Matt, this is where you would want to pay attention. So conducting these 25 kilometers of stream surveys, we got a pretty good look at where the fish are distributed. What you're looking at is a histogram of the fish abundance, so it's fish per 100 meters. The blue bars are West Slope cutthroat trout, the red bars are brook trout. And the thing that jumps right off the page at me is that between stream kilometer 3 and stream kilometer 16, we have almost no trout. So we got a small pocket of trout right in here, but we have a very large section where there's almost none. In the same corresponding stream section, we have, so in green, we're looking at long-nosed sucker. Here in black, you see that we have this pit-tagged subsample. But we have a large section of almost, I guess, from stream kilometer 7 to 16, where we have almost no trout. You have actually a pretty high abundance of long-nosed sucker. Sucker are a different family of fish, so there's something going on in that part of Silverbow Creek that the trout clearly don't like and the sucker clearly do like. The other thing to notice is that the scales are different. So we're looking at, almost 70 suckers in 100 meters, whereas up here, the highest we see is about 23 trout. I know that Nick has pointed out, I think, that there's also a little drop you see here. This is right about Oregon Street, and there is a little bit of a drop in fish abundance as you get downstream. So it's right about Oregon Street, but somewhere in Blacktail there seems to be a drop. That's something certainly worth noting. But more than anything, I want to make it clear, there's 13 kilometers where there's almost no trout, and that's not normal. And so what happens? Well, at stream kilometer 18, that's where the sewage effluent from the Butte plant comes in. Curiously, we do have a little pocket of trout immediately below, and most of those are west slopes. And then at stream kilometer 3, right as we get again, west slope cutthroat trout start to show up, that's immediately above that. That's where the Browns Gulch tributary comes in. So Browns Gulch was not affected. Browns Gulch, while it is grazed and would probably receive at least some nutrient loads from cattle, it's nothing like Silverbow Creek. Oxygen levels tend to be high. And so when we overlay our dissolved oxygen samples, so the first sample I took during this July electrofishing run was on July 12th. And you see that as you go downstream, so here's mostly Blacktail Creek, dissolved oxygen levels stay steady, and then they start to sag a bit and then recover. And generally, you see this sag between stream kilometer 10 and 15. It really kicks in between about stream kilometer 16 and stream kilometer 14 here. 1 week later, as we get further into the summer, dissolved oxygen levels are dropping a little bit lower. But actually, these are quite low. So we're down to 4 milligrams per liter. EPA, or sort of baseline EPA standards are at 5. Trout tolerance is, well, there's lots of ways to measure it. And a week later, we're down now to about 3 milligrams per liter. These are getting towards survival thresholds for trout. But these are sort of snapshot measurements. So when we look at our 24-hour data here in the hypoxic zone, what you see is that actually when we measure these low nighttime levels, they're actually staying low from about 11 o'clock at night all the way till 8 in the morning. So this is actually measuring lower than what we measured with the handheld, but we're talking about 9 hours. So not only does it get severely hypoxic, it stays severely hypoxic. I think there was a study I read that 1.8 milligrams per liter for 10-hour exposure killed 100% of trout in one experimental study. So these are right at threshold in experimental conditions, what kills 100% of trout. We then wanted to look at how are these fish distributed in August, a month later, when we sort of anticipated that dissolved oxygen levels would be perhaps even lower. We found that generally the pattern of abundance is about the same. You're looking at way fewer. This is just the subsample now of pit-tagged long-nosed suckers, so of course there's fewer. We start to see maybe some schools developing among those pit-tagged fish, but largely we see the same pattern, or actually almost entirely we see the same pattern. But what changes is that dissolved oxygen now is very hypoxic. We're now below 2 milligrams per liter. I think we're down at 1.6. We see a very rapid drop on August 3rd. It's sort of steady recovery. The following week, exactly the same. So on August 10th, we're seeing drops of 5 milligrams per liter over 2 kilometers. It may have even been worse, I think, the year before when you all did your study. And then unfortunately, I had to take an exam during the middle of August, so this sort of got strung out, but I missed a sample week. But by the end of August, we're seeing temperatures sort of lowered. We're seeing dissolved oxygen is starting to flatten out. Now, in December, we also conducted a survey between, I think, December 3rd and December 9th. And we see that the pattern looks pretty much the same. We're seeing a little bit of an increase in trout abundance in this formerly hypoxic zone, although my advisor warned me, don't say that. It's not really enough to point out yet, but he's not here. But this was, to me, a really interesting time, because in December, stream temperatures are much different, and the water chemistry is going to change a lot, and the effects of this ammonia on the oxygen, we expected to be quite different. And in fact, when we were measuring dissolved oxygen levels, it's up around 8 milligrams per liter, like 70% oxygen saturation in the water. So dissolved oxygen isn't at least as much of a factor. Well, it shouldn't be nearly as much. Again, we measured it right after our survey. Again, it's still high. Temperatures had rose quite a bit between December 2nd and December 12th. So that somewhat explains why dissolved oxygen dropped a little bit. But we don't see any severe hypoxic zone the way we saw it in the summer. I mean, in this section where that severe hypoxic zone formed, we don't see that. But on the other hand, what we do see in December, what also may explain why we're not seeing trout, is that the ammonia concentrations here in early summer, early September, we see this immediate spike right below the water treatment plant as we expect, and then a gradual sort of decay or drop in ammonia over time. Then again, in late October, we see the same sort of function. Here, I think the temperature, the water temperature was about 12. It's about 6 in late October. But then by December, on December 2nd, when the average temperature in the stream was about 2.5, we see this ammonia conversion to nitrate, or this drop in ammonia, is much slower. And so the levels of ammonia in the stream spatially were much higher for a much longer period. So potentially that could be explaining why we're not seeing a dramatic increase in trout in that part of the stream. So to summarize, I think if nothing else, as Matt pointed out, trout have returned to silverbow, and there are places where they're actually fairly abundant. But there are severe challenges. Hypoxia, I think, is the biggest. And these dissolved oxygen and ammonia levels vary very much on a 24-hour and also on a seasonal cycle. And we need very detailed information to get that. And thankfully, we just got a grant from the Greenway Service District, and we hope that if I can talk Shane into working for me, that we have somebody to get some of this data to help me out with it. But I think that the implications of the work so far are that if that sewage effluent, which we think is the #1 problem, if that's improved and if those conditions are improved, when we start seeing these pockets of west slope cutthroats, and they're kind of on the margins of where this hypoxic zone is, we see a lot of reason to believe that we may see an expansion of those west slope populations into the remediated part of the stream, which we think is very encouraging. So that's it, if there are any questions. This is Ben, by the way. He found a message in a bottle when we were in Blacktail. He tracked down the kid who littered. So that's it. Thank you.